So welcome back again in the next video of the previous series, and in the previous video we have discussed about the Coulomb's law and the Coulomb's law in vector form. That's about how the charge attract to each other, how the charge repel each other. This is on the polarity of the charge. Now in this video we will discuss if we have a multiple charge, more than two charge, and we want to find out the force due to all these on a particular charge, then what will be the net force. So in this video we will discuss about the superposition principle and how the superposition principle used in case of this one. So our topic is the force between the multiple charge. Force between multiple charges. And in the same class, in the same topic, we will discuss principle of superposition. Principle of superposition. So we know when we have more than two charge, so when we talk with the force between the two charge, so these two charge maybe attract each other, maybe repel each other. So whether the force of attraction between them or whether the force of repulsion between them, that means there must be the direction of the force. If the charge repel, then what will be the direction? If the charge attract, then what will be the direction? Now in this video we have a bunch of charge. Then on a particular point, on a particular charge, the multiple force acting. The one on the same charge, there is a force due to the 1, due to the 2, due to the 3, due to the 4. So, and it's at a single point, at a single charge, there are the multiple force, and each force are directed in a different direction. So what will be the net force on that particular one? So suppose that is the x-axis, here is the y-axis, that is the origin. Here is the charge q1 at a position vector r1. Here is the charge q2 at a position vector r2. There are many charge q3, q4, q5, q6 up to the charge Qn at a position vector Rn. So these are the charge, and due to these charge we have to find out the force on a charge Q0, which is your test charge, can be assumed as a test charge at a position vector R0. So our task to find out the force on Q0 due to these one. And these charge accept the force on the charge Q0, and the force are directed in a definite direction. So before finding out the force, let's join the Q1 to Q0, join Q2 to Q0, and join Qn to Q0. So what will be the separation leading from Q1 to Q0? So as we know from the vector algebra, this is R1 and this is R0. So this, what will be this vector? So when we use the triangle law of vector addition, the sum of this one and this one must be equal to R0. And the sum of vector O Q1 plus Q1 to Q0, that is equal to O to Q0. That means Q1 to Q0 must be equal to R0 minus R1. R0 minus R1, and this can be written as R10. This is the vector leading from Q1 to Q0. Similarly, what will be the vector leading from Q2 to Q0? That is equal to R20. and the vector leading from q naught to qn to q naught, that is equal to vector r n naught. So these charge q1, q2, q3, q4 up to qn exert the force on q naught. So what will be the direction of the force on q naught due to q1? The direction of the force on q naught due to q1, these two charge having the same polarity, so q1 repel q naught, and when q1 repel q naught, then this is the direction of the force on q naught due to q1. In the same way, when we see the force on q naught due to q2, then the q2 repel q naught, and this is the direction of the force on q naught due to q2. Similarly, when we see the force on q naught due to qn, then qn also repel q naught, and this is the direction of the force on q naught due to qn. So at a single point, at a single charge, there are the different force are directed in the different direction. So what will be the net force? So to find out the net force, in this case, we will use the principle of superposition. And according to the principle of superposition, when a multiple force acting on a single point, then the net force must be equal to the vector sum of the force exerted by the individual charges. That means इस पॉइंट Q नॉट पे, पॉइंट चार्ज Q नॉट पे जो नेट फोर्स होगा वो किसके बराबर होगा? दैट मस्ट बी इक्वल टू द वेक्टर सम ऑफ द फोर्स एक्सर्टेड बाय Q1, Q2, Q3 अप टू Q1. So just find out the force due to each one individually. So now the force on Q naught due to Q1, and that is equal to F naught 1, the force on Q naught due to 1, and this is equal to 1 over 4 pi epsilon naught Q naught Q1 upon what will be the magnitude of the separation leading from Q1 to Q naught, that is equal to the vector R1 naught, और इसका जो magnitude होगा that is equal to R1 naught square, 1 naught square. And what will be the direction of the force? The force is leading from Q1 to Q naught, so that can be written as in the direction of unit vector R1 naught. Similarly, when we see the force on Q naught due to Q2, and that becomes the force on Q naught due to Q2, and that becomes F naught 2 is equal to 1 over 4 pi epsilon naught Q naught Q2 upon the magnitude of, and what will be the separation between Q2 to Q naught, that is vector R2 naught, और इसका जो magnitude होगा that becomes the magnitude of R2 naught square, and what will be the direction of the force directing from Q naught to Q2 to Q naught, इस force की जो direction होगी that leading from Q2 to Q naught, so in the direction of the unit vector R2 naught. Similarly, we can find out the force due to the Q3, Q4, Q5 up to the Qn due to Qn. And what will be the force on Q naught due to the charge Qn? That becomes the force on Q naught due to n, and that becomes 1 over 4 pi epsilon naught Q naught Qn upon what will be the separation, that is the vector R1 naught, और इसका जो magnitude होगा that becomes in the magnitude of Rn naught square, and what will be the direction of the force? The force is leading from Qn to Q naught, so that becomes in the direction of Rn naught. So at the same point, at a single point, there are the multiple force acting. So the net force in this case becomes the vector sum of the force exerted by the individual charge, and this is the superposition principle. So net force on Q naught due to other can be found out with the help of the principle of superposition, and according to the principle of superposition, the net force must be equal to the force exerted by the individual charges. That means the force exerted by the one, the force exerted by the two, plus the force exerted by the other, up to the force exerted by the nth charge. Just put the value of these charge, then we get 1 over 4 pi epsilon naught q naught q1 upon r1 naught square in the direction of r1 naught, plus the force due to the q2, that is 1 over 4 pi epsilon naught q naught q2 upon r2 naught square in the direction of r2 naught, plus up to qn, that means 1 over 4 pi epsilon naught q naught qn upon r n naught square in the direction of r n naught. So when we see the expression, what will be the common in this expression? The common is 1 upon 4 pi epsilon naught. यहाँ भी है, हर term में involve होगा. And the same, there is a q naught which is also common. So take 1 over 4 pi epsilon naught and q naught as a common. Then the remaining one, that is the q1 upon r1 naught square in the direction of r1 naught, plus q2 upon r2 naught square in the direction of r2 naught, up to qn upon r n naught square in the direction of r n naught. This is the force on a test charge q2 due to the multiple charges. This is the expanded form of the expression. If we write this expression in a single term, we can also write this expression in terms of summation. And when we write in the form of summation, then we have to see, is there any kind of discontinuity? So there is no discontinuity in the entire term. 1 due to the 2, due to the 3, due to the 4, up to due to the n. So we can just write in terms of summation, and to write in terms of summation, that is the q naught over 4 pi epsilon naught summation. Now the charge vary from 1 to n. So there is a term iota goes from 1 to n, and just pick any one term, कोई एक term pick कर लीजिए and just replace the variable by iota. That becomes qi up to r I naught square in the direction of r I naught. That is the force due to the multiple charge. Here you can also expand this, you can also write this unit vector in terms of vector and magnitude. So when we put the value of vector r, unit vector r I naught, the unit vector is equal to vector upon magnitude. So this can also be written as here q naught over 4 pi epsilon naught summation I goes from 1 to n qi upon r I naught square, and here the unit vector r I naught can be written as vector r I naught upon magnitude of r I naught, and this becomes the cube. So the equation reduced to q naught over 4 pi epsilon naught summation I goes 1 to n, and that becomes qi upon vector magnitude of r I naught cube and vector r I naught. That's the force due to the multiple charge on a test charge. So that's all about this topic. So this is complete regarding the Coulomb's law. Now in the next topic we will discuss about the electric field, how the charge exerts the field around itself, and what are the different factors. Okay, so we will discuss in the next video. Thank you so much.